The very large gravitational waves that can be detected by the pulsar timing array are evidence of some sort of fluid behavior to the galaxy as a whole, and the evidence of some sort of fluid behavior to the galaxy as a whole, and the capability for the motion / expansion of the universe and our relation to other galaxies to be altered with time and position. So what I'm trying to say is that there's a thing called the pulsar timing array, which is basically we are looking at multiple pulsars in multiple areas, and since pulsars give off set time intervals of signals, we can use that. We know what their set intervals are, and so we can compare its set interval with other set interval like pulsars. And when we notice a distortion in this timing, right, we can go, wait a minute, the pulsar's timing was slightly elongated at this point, right? It's a little distorted. And we can kind of use that, and by looking at multiple pulsars in multiple areas, we can conclude that it's not just the pulsar being weird, it's actually there's a sort of wave, like a gravitational wave that is distorting our observation of this, right? And so I think this is just one of the coolest things ever. But the fact that this is a thing is very interesting, and to me, shows that if there's just very faint gravitational waves that are slightly warping, basically our perception of time, and this is at the very small scale, then it also points to that time could be distorted at, larger scales. And so when we try and figure out what the rate of expansion of the universe is, it's kind of hard to pin that down because, well, if at certain times we were getting hit by different gravitational fields, different gravitational waves, that could have had a big impact on how time moves and what our observed rate of time is. And it would make it look like at some points we were expanding more and some points a little less, right? And this is interesting. And so I also think that this points towards, since we notice different looking out, we notice these waves at different times, this could also point towards our relation between different galaxies is shifted over time. Because if these small waves can have a small impact, then there's no it builds the basis for the potential for our relation between other galaxies and other faraway objects to change with time. And so but what I really want to get into is that the background gravitational fluctuations we've detected seems awfully familiar to the vacuum energy fluctuations. Maybe this is because they are the same thing at different scales. What do you think a sound wave looks like to a photon? And so what I'm saying with this part is that we have observed the vacuum fluctuations. So there's this fluctuation in energy at the vacuum, in the vacuum, which is just the smallest scale that we can really observe. We pull everything out and we still observe a fluctuation going on. And we ask ourselves, well, why would we observe this? And it's because we're observing fluctuations in dark energy, which is the fluid that we are in. But, no one wants to believe that right now for some reason. And so, if we observe fluctuations in dark energy, doesn't it make sense that we would also observe fluctuations on a larger scale, right? So, if you imagine, right, that electromagnetic radiation is waves, being emitted, right? Then if you observe these waves, like if you were at a small enough scale to observe these waves, right, then you would be like, whoa, that's a big wave, right? But these waves would be way, 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 way smaller than that of a sound wave. A sound wave would appear to be a much larger, more distributed, more spread out wave. It would be of seemingly lower energy, right? But it would be a much larger wave. So when you think about, if you were at the scale of an atom, right? You're standing on top of an atom and you see an electromagnetic wave fly by, right? It's gonna be like, whoa, right? And then if you were to then see a sound wave reverberate through, you're going to observe that completely differently. It's going to appear completely different. However, the behavior is relatively the same. The problem is that I am trying to explain a concept to, in my opinion, makes complete sense and tracks, one to one. They're all the same thing, basically at different scales. However, the current belief is not they would say, well, electromagnetic radiation is not the same as sound waves, but I think that it is. It's just at different scales. However, I can't do anything to, prove otherwise other than say that, at least not currently. And so, I'm trying to make an argument that I think is logical, and now I'm realizing that a lot of the logic is mainly on my side, and everyone else has to just kind of go along. Anyway, the fact that there is uncertainty into the source, as some think it is a background hum, while others think it is just from black hole mergers spewing them out. This is talking about the source of this background, basically gravitational wave fluctuation. The source is not totally certain. We know that gravitational waves can come from black holes and black hole mergers. However, I don't know if we've actually observed black hole mergers happening. I don't know. I thought there was a thing that black holes shouldn't merge or something along those lines, like the final parsec problem, which I did a talk about. But I could be wrong about that. Maybe I'm missing some information. But we know that in theory that should create gravitational waves. Or maybe just them, maybe they don't even need to combine, just as they oscillate or as they rotate around each other. Even though they don't technically, combine into one, they still are spitting off a ton of gravitational waves. That would make sense too. That would be fine. And so the theory is that, well, they don't really know exactly where they're coming from, but some people think it's from basically these black holes, rotating around each other and spinning up the, I guess, just space-time. I don't even know what these people think gravitational waves are, to be honest. If you don't think that, they say it's a fluctuation in space-time, but it just, I don't know, it just doesn't, I don't understand why no one thinks that my theory is right. But I guess that's a me problem. Anyway, the fact that we're uncertain about it, I think is interesting. I don't see these as mutually exclusive, and I think that it is reasonable to say that it is a constant background that is produced by black holes, right? So some are saying that it could be just a background hum, but it just makes sense that everything is, putting off vibrations, and so it just makes sense that, you would observe some level of vibration just because everything is kind of giving off some level of stuff, right? So if you were if you had a little pool and you put, you know, a bunch of rubber duckies or something into the pool, if like wind blows through and they move a little bit, they're gonna rock a little bit, right? And then they're gonna put off waves, right? And then you're gonna end up with like this very slight amount of background ripple, right? That's just everywhere, right? So you observe this background everywhere because over time, eventually, this rocking will produce waves everywhere. However, the source of them is not coming from everywhere. It's coming from these rubber duckies. However, the rubber duckies, are now also, I don't know. The source is the rubber duckies. However, after time, you will observe these waves coming from everywhere, and they will kind of merge and create a really chaotic fluctuation over time if there's multiple rubber duckies that are bobbing around. If there's just one, then it's going to be, a relatively calm, wave. But once you have two or three in there, all of a sudden now it's just getting crazy. But that's as far as I'm going to go with that, so you don't say that a fan in the background, right? Okay, so this is another analogy that I want to say. So we're saying, hey, like, it's like a background hum, right? And other people are saying, no, it's coming from the black holes, right? But you wouldn't say that, like if you have a fan on in the background, right? Okay, so there's a background hum from the fan. You wouldn't say, no, it's not coming from the fan. It's just a background hum, right? It's both. It's both a background hum and also coming from the fan. And so, the noise needs to come from something. We observe this in sound waves and light waves. Why would this change at smaller and larger scales? And so basically what I'm saying is that everything has a source that we've observed, right? We could argue that the vacuum fluctuation has apparently no source. I would argue that it does. We just can't observe what it is. And as I said, that requires you to believe my theory rather than another. And so I'm not going to worry about that. But on scales that we can observe, we know that every action has a cause. And so if it's true here on this level, why would it not be true at a larger scale, right? Why would they just be a thing? Why would gravitational waves just be like a thing that happens on the larger scale when, waves in a pond don't just happen? They are there because something caused them, right? And that's just the backbone of my whole theory and why quantum doesn't make any sense, because it just gets back to, well, what caused quantum to work? And the answer is, and so I don't like it. I don't like that there's no more room there's no deeper to go. I don't think that makes sense. And the argument is that quantum's weird and it doesn't make sense. And the argument that I make back is if it doesn't make sense, then it's probably wrong. But, who's to say? And so, yeah, peace out.